There are different notations for the instruction of deriving or finding the derivative, and you can read them or interpret them differently. Like the previous question used dy dx, which shows you which equation and which variable you should find the derivative for. Whereas this one is more of an instruction, which tells you for the expression that is inside these brackets, find the derivative with respect to x. So we'll keep this instruction up until we fulfill the request. And we cannot do that right now, because in order for us to use the methods, the quick method of finding the derivative, we need to ensure that x is not a denominator, and also that x has a power that is clearly visible. So here we have x as a denominator and we have x underneath a square root. What we're going to do is we are going to remove the square root by using one of the laws of exponents, which would leave this being x to the power of 1 over 3. Don't forget the negative, and that is over 2. So it's technically under a cube root, and the way that this works is if you have x to the power of a and you're taking the bth root of any variable, this will become x to the power of a over b. And in our case, b is 3 and a is 1, since it's not written anything. So we know that this will simplify to 1 over 3. So that is that. And then over here we have this square. What we're going to do is we first have to deal with what's on the outside before we can deal with what's on the inside. So I'm going to square everything within this bracket. So 1 squared, that's going to be 1. 3 squared, that's going to be 9. X squared, that's going to be x squared. That's all I can do for now. Then I'm almost there. All I need to now do is take this x squared and put it above. But how do I do that while conserving this expression? So on my next step, differentiating x, I'm gonna write this as minus 1 over 2 multiplied by x to the power of 1 over 3. This helps to differentiate our coefficient and our variable that we need to differentiate. So that is that, plus 1 over 9 multiplied by x to the power of negative 2. So the reason I've done this is because when I want to take a variable from the denominator and put it in the numerator, or from the numerator and put it in the denominator, the only thing that you have to do is change the power or change the sign of the power. And in this case, I changed it from having a power of positive 2 to a power of negative 2, and that allowed me to put it on top, and then I just wrote it separate to our coefficient, so we can clearly see the coefficient and the variable that we need to differentiate. So in this step now, I no longer need to write dx, because now I'm going to perform this function on each and every term that is in here. So I'm going to differentiate this first term in terms of x. That will be multiplying minus 1 over 2 by 1 over 3. I get minus 1 over 6 x to the power of 1 over 3 minus 1 gives us minus 2 over 3. Move on to the second one. 1 over 9 times negative 2 gives me negative 2 over 9. And then x to the power of minus 2. If I subtract 1, I get minus 3. And then I can simplify it even further, because most mathematicians don't like leaving their answers with negative powers. I'm going to do what I did, the inverse of what I did over here. So I'm going to have negative 1 over 6 times x to the power of 2 over 3. So I've taken this from the numerator to the denominator by changing the sign of the power. It was negative and now it is positive. And then I'll do the same thing here with the minus 2 over 9 x to the power of 3. So that's the general trend. Whenever you have something like x squared over 3, if you want to move it down, you just go 3 and then move the x squared there, but you change the sign, make it negative. This and that are equal. It means the same thing, just different ways of representing it. Then that is that.